So today we are looking at the force on a plane, frictional force on a plane. The question said a mass of 20 kg is placed on a plane inclined at an angle of 30 degrees to the horizontal. What force parallel to the plane is required to hold this mass at rest? We have coefficient of static friction to be 0.4 and our gravity to be 10 meters per second. So what do we do here? The first thing, we can make a sketch of this to make it easier for us. So taking a sketch of this, we know that the force is going up, and then we have normal reaction here, and then we have the weight going down. This weight is then, the weight will then be times 10. That will give us 200 Newton. So what next? You say the force that will hold it required to keep it at rest at this inclined plane. We can call that force, let's maybe P, or okay, let's use P. P will be better. That is meaning pulling it up. So now this is what is going on here. Already normally under this condition, we know that if we resolve all these forces here, if we resolve it, we know that we have another force. We have this will be, this F is equal to normal reaction, sorry. This is what we have. This F will be coefficient of static friction times normal reaction, which is this. And normal reaction is always equal to this. But now, because it's in inclined plane, we resolve it considering the angle of inclination. So what do we have here? And we know that another force on this plane, which is, since this one, P plus P, F, P plus F, P plus F is equal to the force, the vertical component of this force inclined here. The vertical component of that force is 2000 sine 30 degree. That is what we have. This P plus that will give us that vertical component. And we know that the normal reaction is equal to what? 200 Newton. Okay, let's just save that down. We have that is our horizontal component now. That is what we have. So for us to, what we are looking for now is this force. And we also know, if we substitute, we can substitute this. We can substitute this for F in this equation. If we substitute for F there, what are we going to get? It will mean, for this first equation, if we substitute that, what we have there, we should be P plus F equal to 200 sine 30 degree. That is what we have. Then we can add this for that, and the other one. What do we have for coefficient? Coefficient is 0.4. Maybe we'll take up a bit. Let me clean something up here. And meanwhile, these questions will also be in the description of this very video. It will be there so that you can always look at it as we are solving it. So what we have here should be, if we substitute everything, we have plus 0.4 brackets, what, 200 cos 30 degree bracket equal to 200 sine 30 degree. So I believe we are together in this. If we are together, then let's see what it will look like. Let's see what it will look like. Sine 30 degree multiplied by 200 Newton, we have here, we have 100. So let's go over to the other end. We have cos 30 degree multiplied by 200. We have, that would be p plus 0.4 bracket 173 approximately equal to 100. So this is what we have here. So the next one is that we multiply this through. What we have is 3 p equal to 100. I believe you are following. Please leave your question in the comment section if for any reason you are not really understanding. I will put you through. So the next thing is we'll collect like terms. If we collect like terms here, we'll have it will be equal to 100 minus 69.3. So what do we have? So what we should have will be minus 100. Then we'll have is equal to 30.7 Newton. That is what the force that we need to hold it at rest. So I think it's very simple, right? It's very simple, very simple. You can see how simple it is. Sometimes when we see these questions, sometimes it seems to be a bit scary. But don't let this scare you off. So you can see how easy it is. So thank you for being part of the class and at least getting to this point. And if you are joining for the first time, we want to encourage you to what? Just subscribe. Help us. Just encourage us to do more. That's a way of encouraging us. Make sure you like if you really getting value from this video. Make sure you like it and make sure you share it and leave a comment if you have anything you want to tell us. Thank you so much.